need to make a clean break there because we're introducing an entirely new document, and this document is called the standard normal table. Okay, and it gives you probabilities for things like this that are not specifically part of the empirical rule. Okay, so we can get very specific here. This is what the tables look like. Okay, I'll point some things out to you. You'll notice the shaded region. This is the normal distribution, and it's labeled here as a z. So what that basically means is whatever your value of z is, if you look at the table and you find the z value, here's not only a z here, but it's z located on the table. Now z, this is the second decimal past 0, and this is the whole number and the first decimal past 0. So if we're looking up and we want to go back to this problem here, and I estimated around 85%, but I got a z value of 1.08. Okay, if we have a z value of 1.08, meaning we're a little more than one standard deviation above average. If I look at my table here, well, first of all, you'll see that there's two sides to it. Okay, the shaded region on the left side here, on this zone, you'll notice that every one of these numbers is negative. And that should make sense, because if this is the mean right here, then any z value that's to the left is going to represent a value that is below average. Well, 1.08 is actually above average. Well, that's what this side of the table is for. Okay, you'll notice the shaded region here starts to the right of the mean. Okay, so everything in this side of the table is going to be more than 50%. You'll notice everything in this side of the table is going to be less than 50%. It goes down to 0.0003 all the way up to about 46, around 40, well, no, sorry, this is the corner, up to 50%. Okay, 0.500. It's hard to see here. You'll need to get one of these on your own, and in theory, if you were here on Friday, then you have it. So maybe I'll zoom in, right? I don't know. Yeah, why not? That helps a little, I think. So let's go back to here. We're looking up the probability that a z value would be 1.08. And again, the question is, what's the probability that a baby weighs 1.08 standard deviations above average, or at least or less? Okay, and again, the or less means that it's shaded to the left. So we're looking at only values that are that much or less. So there's my 1 point section. There's my 1 point, well, not 8, it's 1.08. So I want the 1.0 here, but then on that kind of white row here, you're going to cruise all the way across until you get to your 0.8. So 1.08, if you go down in that column until you get to that row right there, 0.8599. Now I was a little bit low on my estimation on my 85%. But in fact, it should be 0.8599. So that is specifically, that wasn't a bad approximation. I didn't even know better. So let's go back and do this same thing for 11 and 3.2. Now, the nice thing is, a moment ago, we calculated the z values for 11-pound baby and a 3.2-pound baby. We also said it's very unlikely to get a number that high. Okay, but it's still on the table. Now, that's a positive number. So that means we're going to go on the positive side of the table. And that positive number was 2.62. Well, there's my 2-point section. There's my 2.6. 2.62 is going to follow along this line right here. So 2.6012, that right there is the probability that a baby weighs 11 pounds or less. That's 0.9956. So 0.9956. Now you're going to find this one's even more remote. Okay, kind of exciting. 3.2, but where is that one going to be located? Well, 3.2 pounds meant we had a z value of negative 3.38. Okay, so if we go over to our other table, the negative side, there's my negative 3 point. There's my negative 3.3, and my 3.38 is all the way over here. 0.0004, 0.0004, a very unlikely event. Now, why is that one so small and that one so big? Less than, okay? That is one of the highest baby weights that we have on record, okay? Kind of, maybe not. I don't know if this is real. But 11 pounds is a big baby. It's going to be more than most of the data, okay? Very small baby. Also an extreme weight, but it's on the low end. So what's the probability that a baby is less than this value? It's 0.0004. So keep that in mind. If we ask, and we will, what's the probability that it would be more than, you still need to use these tables. You'll then need to subtract that number from 100%, and we'll get to that.